Hello everyone, welcome back to ECA Core YouTube channel. Today we are going to start our first lecture in digital electronics. Before starting these Boolean theorems, I would like to discuss about the chapters or topics that we are going to cover in this series of digital electronics. First, we are going to see the Boolean theorems and logic gates. We will learn all the Boolean theorems, duality theorem as well. We will also learn about multivibrators as well in this chapter also. And then after studying multivibrators clearly, then we will go into logic gates. And then with the logic gates, we will complete this chapter. After completing logic gates, we will go into next chapter that will be combination circuits, where we will learn about after where we will learn about multiplexers, decoders, encoders, and sequentials. And coming to sequential circuits, we will have flip-flops, latches, and we will study in detail about them. And then we'll go into ADC and DSC, and we will also learn about finite state machines as well. This is the topic that we are going to cover in this series of digital electronics. First chapter that we are going to start it is Boolean theorems. First we are going to learn the theorems that are related to OR operation in Boolean theorems. So let us go into OR operation properties. First one. First, if I'm taking a plus 0, then my answer will always be a. If I'm doing a plus 1, my answer will always be 1. I will explain this again. First, I will write all of them. If I'm doing a plus a, then my answer will always be a. If I'm doing a plus a bar, then my answer will always be equal to 1. So why this? If you know that if I'm taking 1 plus 0, then my answer will be 1. So here I have my answer, mine is a. If I am taking a is equal to 0, then 0 plus 0, that will be equal to 0. Similarly, why a plus 1 is equal to 1? It must be a, right? If you think that way, see, if I am taking a is equal to 0, then my answer will be 1. That is what 0 plus 1, that is equal to 1. If I am adding, if I am taking a is equal to 1, then my answer 1 plus 1 will always be equal to 1. So by this property, we will understand that if we are adding 1 to anything, then my answer will always be 1. Similarly, if you do a is equal to 0, then it will be 0 plus 0, that will be equal to 0. And if a is equal to 1, then I am doing 1 plus 1, that will always be equal to 1. See, whatever a I am taking, then my answer will always be a. Similarly, if you do this one, 1 will be equal to 0 and 1 will be equal to 1. So that my answer 1 plus anything will always be anything. So from these derivations, from these solutions, what we can write as, if I am adding 1 plus 0, my answer will be 1. If I am doing 0 plus 0, then my answer will be 0. If I am doing 1 plus 1, my answer will always be 1. So in order to clearly understand, I am going to give you a simple question here for you to solve. So let us see what is the question. I am giving 1 plus a plus a bar b plus cd. What is the answer for this one? So after this one, I am gonna sell to one of the most important and easiest way to solve the OR operations. You can solve in 1 second if you are given this type of problem. So what we have said in this second theorem, if I am adding anything to 1, my answer will always be n. Whether it may be 2 variable, 3 variable, any number of expression it may be. If my first one is 1, my answer will always be 1. From this, what we can write is 1 plus anything will always be equal to 1. I think you understood this one. 1 plus 1 is equal to anything. So these are the operations related to OR. And this is the conclusion that we can draw from this. So remember, this is the most important, which will help you solve Boolean expressions in And those who don't know this one will always try to solve this one, where they answer in the question you will not even have the values of any one of this. So you will get stuck in between. If you don't know this one, 1 plus anything is equal to 1, you will always get stuck here. So for that, if you remember this one, you will write, okay, if I'm 1 is there, 1 plus anything it may be. You don't need to read the equation also. Write 1 plus anything, and that would directly equal to 1. That's all. And next we will see the properties that are related to our operation as well. First one, that will be a dot 0, a and 0, that will always be equal to 0. If you multiply anything with 0, that is if a into 1, then my answer will always be a. Similarly, if I am multiplying a into a, my answer will always be a. And if I am doing a into a bar, then my answer will always be equal to 0. Why? Because if I this one I am taking as if I am taking a equal to 1, then my a bar will be equal to 0. So my answer will be 0 into 1. My answer will be equal to 0. I think you understood. That's why my answer, whether you take 0 also, then you will get same answer. If for a into 1, if you take both are same, then you will get same. For a is equal to 0, you will get 0 into 0, that is 0. A is equal to 1, you will get 1 into 1, that will equal to 1. So my answer will always be a. If you multiply anything with a, then 1, you will get the same one. And if you multiply with anything with 0, you can get 0. So what we can conclude from this expressions is 1 into 0 equal to 0. 0 into 0 equal to 0. If 1 into 1, then it will be equal to 0. So I am going to give a simple question related to this one. If I am having same similar like AB plus CD plus A bar B into 0, and what can you write? You can directly write 0. Since how we are having 1 plus anything is equal to 1, if you are doing 1 into anything, 0 into anything, then my answer will always be equal to 0. This is the most important one in AND operation. And let's solve one problem here. See, A into B C bar into D bar into EF. So I'll try to solve this one. And I will also solve mm, into E F. So what will my equation be? See, if D is equal to 1, what we can how can we solve this one? If D equal to 1, then my D bar will equal to 0. If I am multiplying anything with 0, my answer will be equal to 0. You need not just simplify one value and you will get the whole answer. And this is one of the most important one in AND operation. 0 into anything is always equal to 0. Then we will learn some important Boolean theorems as well. Coming to this first one, if A into B plus C, what will this is the distributive law. If you do this, what will it be? Please tell me what will be. A into B plus A into C, right? Similarly, if I am doing A plus B into C, then my answer will be A plus B into A plus C. So what can you observe here? What is the sign that is here, that is being distributed over the variables here? So what we can write from this here, and is distributed over R, and here you can write R is distributed over n. I think you understood here. This is the one distributive law. And coming to next one of the most important property of Boolean algebra. If I'm having a plus a bar b, my answer you may try to solve, but I will simply write a plus b. So let us solve this one. I am doing a plus a bar and this one. What will my first my will be a plus a bar. R is being distributed here. So a plus b. And what you can write from this? A plus a bar will always be equal to 1, and 1 into anything is and that one, then that will be equal to a plus b. I think you understood this one. So similarly I will write for 3. If I will take one as 3 variable d, I am writing a plus a bar bc, then my answer simply will be a plus bc. If my answer whether it may be a bar plus a b c d, then my answer will be a bar plus b c d. Did you understand this one? This is one of the most important one. You need to remember this one because we will use in many number of equations you will get while solving big boolean expression. You will get number of variables like this, then you will get will be it will be easy for you to solve that way. So I will next we will learn about one of the most important theorem in boolean theorems. See, let us take an example. If I am having ab plus ac plus bc, this one I will keep bar here. So what will my output expression be? Don't try to solve this one. Let us see here. Let us let us see if there are all the variables appearing twice. So here all the variables are appearing twice. So I will check what is the which variable has the complement here. You can see a and a bar are having complement, right? So what I will do is I will check the coefficients of these two a and a bar, and if these coefficients are there in the third expression, then I will simply write ab plus a bar c. We will eliminate this one. Then this is known as redundancy theorem. Redundancy theorem. One of the most important theorem in Boolean theorems, This will help you very much. And similarly, if I have a bar b plus acd plus bcd, what can I write? Simply I will write a bar b plus acd. C coefficient of b and cd are available in third expression. So I will simply write bcd. Then this order may change if they may give bcd or acd because this law this will be commutative law and this can be in any form. So what we can write is a or b plus ac d. And next, one of the most important of all, that is De Morgan's theorem. Let us see what does the De Morgan theorem actually state. De Morgan theorem has two laws. First one is I need to break the line, and the second one that I am going to have is change the sign. These are the two laws of Boolean theorem. Let us understand this with the help of an example. Let us see if I am first I will take only two variables a plus b bar. I am having this one. Then what I need to do? First I will break the line a bar and b bar. Then I need to change the sign. Then or I will change to dot. And similarly, if I am having a dot b bar, then what can I? First I will break the line, and here it is dot, and here I will dot or. Similarly for if you are having like this, what you can write? First you will simplify this one, a bar b c bar, and that you can also simplify this one with a bar into b bar plus c bar. I think you understood, and you can simplify this one as well, a into b bar plus a into c bar. And I think you understood. Suppose if I am having four variables a plus b plus c plus d whole bar, then what can I write this one as? So if I am having, if the value of any of this is given, I will separate this one. Suppose let us take b is equal to 1. Then what I will do is b plus c plus d I will leave as it is, and then I will write into b bar. Then b is equal to 1, then that will become 0. Then my whole answer will become 0. That way you can easily solve the expression. Before going to next topic, let us solve some problems here. I am going to give some Boolean expressions by using De Morgan's law and Boolean theorem that we have learned. We will solve some 2 to 3 problems, and here I will tell you one of the most important and easiest way to solve the biggest problems if there is one condition to that problem. First, let us solve this small equation. I am giving a plus b plus bc plus a bar c. So let us solve this one. If you want to solve, just pause this video and solve, and after that verify with this one. Let us say if I am taking, let us see if redundancy theorem is applicable here. A and a bar, and three variables are there, and three variables are appearing. So if a and a bar are there, let us see if there is b here and I am having bc, then my b must have been either here or either here. So there is redundancy theorem is not applicable. Then what? And what we have learned, this one is this a plus a bar, we will simply write, and bc. What this one states that a plus c plus bc, right? So here c is common for me, I will write c of b plus 1 plus b, sorry, 1 b plus 1. So what will my equation be? C into b plus 1, I am adding one anything to 1, then it will always be equal to 1. C into 1, a plus c dot 1, that will be equal to a plus c. So this is how you will solve problems. And let us solve another problem. If I'm this will be a little tricky for you if you don't know Boolean theorems perfectly. What we if you learn, if you understood what we have learned up till now, then we will see. So let us check if Boolean theorem is redundancy theorem is applicable here. Here I am having b bar, a bar, and a. Let us check for a first. If I am having a and a bar, then my quotient should be b and c, but I am having b bar. Here b and b bar is also complement each other. Let us see. And if I am b bar and a bar and c should be there, but I am having a. So redundancy theorem is not applicable here. So what I will do is I am taking a bar b as common, and then I am taking c as common. Sorry, a bar b plus c of, from if you are both, then it will be a plus b bar. So how will you solve this one from here? So let us assume that let us assume that we will take an variable x, a bar b equal to x. Okay, using De Morgan's theorem we saw, I am solving here, so please understand if you're so let us solve here. If one question a bar, right, x is equal to, sorry, x is equal to a bar b, right? If I am applying De Morgan's theorem, then I will make this one a bar b, and then I will split the complement here, then a bar b plus b, that will equal to a plus b bar. So what you are saying is you can write a plus b bar is complement to a plus, this is x complement, right? I am taking x complement, then this will be complement of this one. So x complement will be, this will be equal to x complement. So yeah, I will write as x plus x bar c, and what will that give me? X plus c. And what is my x? A bar b, and this will be c. And this is the way you need to solve the problems. So another, this is the most important of all, to solve a big expression. I am going to give a big expression for you. A b bar, a bar b plus b bar c plus a b bar d plus a b bar d bar. Try to solve this one. Pause this video and solve this one. And I will say one of the most important here, important one theorem. Solve this one. If you are not getting this one, then start this video again. First, if I the property I am going to say is, if I am having a variable p into p plus anything, that will be equal to p. So let us say this one a bar b as p. So yeah, I will check if the a b bar is possible, and here it is possible, and here it is there. So what I will write is, I will write a b bar as it is, and a bar b. Here there are two, then I need to make it one. So what I will do is, I will simply take a b bar common here, and I will do d plus d bar. Then d plus d bar is equal to 1, right? So it will become a b bar of a b bar plus a bar b plus b bar c. So here it is p and here it is p. Then my answer will be a b bar. If you solve like this, it will take so much time for you. You can also solve the whole, but your gate rank defines on this the time that you are spending was the questions. Some may take 4 to 5 2 to 3 minutes, and you will simply solve in 30 seconds. Then your rank is high compared to, I mean, you will get much better rank than compared to others. So I will give another question here. Let us see. Yeah, let us solve another question. If I am having a bar plus b bar into b bar plus c bar whole bar, then how should I solve this one? Let us see. I will apply De Morgan's theorem. I will split the complement first, then change the sign into b bar plus b bar into c bar, right? So what will be a into b plus b into c. By taking b as common, you can write a plus c. So this is the answer. And another, you can also take way another way to solve this problem. In one step you can write this one. Let us see how you can do that. If I'm taking b common in here itself, what will my question answer be? B bar, sorry, what will my b bar plus a bar into c bar whole bar, right? So what I can write, I will split b into a plus c, that's all. And here is my answer in one step. This is the way you can solve easy problems. And in next video we'll start duality duality theorem. We will start in next video. So if because the length of this video becomes very high, so we will start duality theorem in next. Until then, take care, bye bye, we will see you tomorrow.